Hello and welcome to the Consider This channel. This is Chapter 9 of Evidence of Soul by Sharon Patrice. Black holes. If you ask Google or any other search engine what is a black hole, it will tell you. A black hole is a region of space where gravity is so strong that nothing can escape, not even light. Black holes are formed when very massive stars collapse at the end of their lives. The mass of a black hole is squeezed into a tiny space, creating a deep gravity sink. The boundary around a black hole where nothing can escape is called the event horizon. Of course, Google gets its information from various online sites, and as no one actually knows the reality of a black hole, it really is a matter of whose guess sounds more reasonable. According to Professor Chris Impey, Honorary Fellow and alumnus of St. John's College, Cambridge, and Honorary Doctor of the University, Professor Sir Roger Penrose's 2020 Nobel Prize-winning work, black holes are an inescapable consequence of Einstein's theory of gravity. He explains, if you fell into a black hole left over when a star died, you would be shredded with no chance of survival. The massive black holes seen at the center of all galaxies have insatiable appetites. And black holes are places where the laws of physics are obliterated. The great and revered Albert Einstein's 1915 theory of general relativity predicted that the gravitational pull of a black hole is so large that black holes warp the fabric of space, but just lately, with the information picked up by the James Webb Telescope, scientists are scrambling to explain things that don't quite fit into Einstein's theory. Many years ago, when I first became interested in black holes, I wondered if the planets being sucked into the blackness eventually got pooped out from the other end. After all, if it were gobbling up planets, then surely the universe, or at least the part we live in, would become noticeably sparser. Now, I'm no scientist, but I do know that after one eats one eventually poos. It is assumed, I say assumed because, quite honestly, I don't evaluate anyone really knows what's going on, but let's go with the given assumption. Black holes of varying sizes, some quite small in comparison to other, consume all in their immediate surround, and they're the matter from all digested planets, and such stays becoming more and more dense in a compact uniqueness. But, like constipation in a human body, the mass must go somewhere. The first insight into black holes was brought to us by a clergyman by the name of John Michell, 1724 to 1793, and like many clergymen of his day, Michell examined subjects other than Christianity. John was also an English philosopher who provided pioneering insights into a wide range of scientific fields including astronomy, geology, and gravitation. He may well be considered as one of the greatest unsung scientists of all time. He is the first person acknowledged to have proposed the existence of black holes and the first to have suggested that earthquakes traveled in seismic waves. Recognizing that double stars were a product of mutual gravitation, he was the first to apply statistics to the study of the cosmos. He invented an apparatus to measure the mass of the Earth and explained how to manufacture an artificial magnet. He is appraised as the father both of seismology and of magnetometry. In a paper for the Philosophical Transactions of the Royal Society of London, read on the 27th of November, 1783, Michell was the first to propose the existence of black holes, which he called dark stars. If there should really exist in nature any bodies, whose density is not less than that of the Sun, and whose diameters are more than 500 times the diameter of the Sun, since their light could not arrive at us, or if there should exist any other bodies of a somewhat smaller size, which are not naturally luminous, of the existence of bodies under either of these circumstances, we could have no information from sight. Yet, if any other luminous bodies should happen to revolve about them, we might still perhaps from the motions of these revolving bodies infer the existence of the central ones with some degree of probability, as this might afford a clue to some of the apparent irregularities of the revolving bodies, which would not be easily explicable on any other hypothesis, but as the consequences of such a supposition are very obvious, and the consideration of them somewhat beside my present purpose, I shall not prosecute them any further. Astronomers saw the first signs of a black hole in 1964, via gas apparently being sucked away from a closely orbiting blue supergiant star. As this gas whirled into the black hole, it became so hot it emitted high-energy X-rays and gamma rays that our satellites could detect. By coincidence, it is a considered opinion the ancient forebearers of farming appear to have looked toward the constellation of Cygnus, where a black hole has been found, as a possible place for where the soul may fly to, and come from according to many views and published works. This is evidential even today when we Europeans send a congratulations card to the parents of a newborn baby. The card often has a picture of a stork flying through the skies with a baby held in a blanket in the bird's beak, the stork representing the constellation of Cygnus. Perhaps a traditional belief brought to us by our historic ancestors? In other religions such as Hinduism, the period of time between 4:24 am to 5:12 am is called the Brahma Muhurta, which means the moment of the universe. The star system in correlation is the Cygnus constellation. This is believed to be a promising time to meditate, do any task, or start the day. It is utterly amazing, and never fails to delight me, how us humans romanticize about things we can see but know nothing about. It's a comfort thing. The Big Bang Theory and human speculation. Back at the beginning of time, as we now perceive it to be, some 13.8 billion years ago, everything in the entire universe was crushed down into an isolated contained location being of infinite density. To say it was a bit tight for space would be an exaggerated understatement. This theory, as a modern mathematical equation, is uncharted, therefore unknown to humanity, but then in some say less than a second, with one enormous explosion everything expanded outward. Astronomers have named this occasion the Big Bang singularity. The term singularity is in reality just a descriptive word meaning our mathematical equations do not stretch as far as to understand the realization of what we are looking at. At the heart of every galaxy is a black hole. And, so my question is, could a black hole be the location of infinite density where we, that is to say, our planetary system and universe came from? In other words, were we the poop that came from a constipated black hole? Up until recently the answer from astrophysicists, mathematicians, scientists, astronomers, and all those who know about such things would have been an implicit no. Mainly, because that would mean our entire take on how the universe developed would be somewhere between slightly off course to outright erroneous. Let us take a look how, with the help of ever-developing innovative technology, opinions are changing. The scientifically recognized view tends to be, despite the early universe being extremely dense, it did not recollapse into a black hole during the Big Bang, since the expansion rate was greater than the attraction. Following the inflation theory here, was a net repulsive gravitation in the beginning, until the end of inflation. Since then, the flow was slowed by the energy density of the universe. It all sounds a little complicated, but do remember we, the human race, are changing our conjecture and theories constantly as awe-inspiring new discoveries are made. As reported by Andrew Griffin and published in The Independent Online on the 28th of July, 2021, scientists have picked up light from the other side of a black hole for the first ever time. Such an observation might seem, not just difficult but outright impossible, given black holes famously eat up any light that goes near them. But, the new study used an unusual effect where light echoes around the black hole, such that scientists can see it from the other side. The detection came after scientists examined X-rays that were being thrown out into the universe by a supermassive black hole that sits in the middle of another galaxy, 800 million light-years away. Those X-rays kept to a strange pattern. After the bright, flaring X-rays, there would be smaller and later ones, which appeared in different colors than those more obvious ones. The report goes on to state, the X-rays looked as if they were being reflected from the other side of the black hole, noticed Stanford University astrophysicist Dan Wilkins. But, such an event would seem highly unusual, given black holes are more famous for destroying light than being a source of it. Any light, he continued, that goes into that black hole doesn't come out, so we shouldn't be able to see anything that's behind the black hole, he said in a statement. But it was another, less famous characteristic of black holes that meant those X-rays could be seen. The reason we can see that is because that black hole is warping space, bending light and twisting magnetic fields around itself. Wilkins explained. The discovery of light emitting from the other side of a black hole was predicted by Einstein's theory of general relativity. But it had never been seen before. Given the eccentric characteristics of black holes, it was long questioned whether such physical objects could actually exist or whether they were merely pathological solutions to Einstein's equations. Einstein himself wrongly thought black holes would not form, because he held that the angular momentum of collapsing particles would stabilize their motion at some radius. On the 6th of April, 2023, NASA released via its online Hubble site, a jaw-dropping statement. A bizarre 200,000 light-year-long bridge links a galaxy to its escaping black hole. It states the universe is so capricious that even the slightest things that might go unnoticed could have profound implications. That's what happened to Yale astronomer Peter Van Dokkum when he was looking through Hubble Space Telescope images and noticed a suspected blemish that looked like a scratch on photographic film. For Hubble's electronic cameras, cosmic rays skimming along the detector look like scratches. But once spectroscopy was done on the oddball streak, Van Dokkum realized it was really a 200,000 light-year-long chain of young blue stars located over halfway across the universe. Van Dokkum and his colleagues believe that it stretches between a runaway monster black hole and the galaxy it was ejected from. The black hole must be compressing gas along its wake, which condenses to form stars. Nothing like it has ever been seen anywhere else in the universe before. The release goes on to explain there's an invisible monster on the loose, barreling through intergalactic space so fast that if it were in our solar system, it could travel from Earth to the Moon in 14 minutes. This supermassive black hole, weighing as much as 20 million suns, has left behind a never-before-seen 200,000 light-year-long contrail of newborn stars, twice the diameter of our Milky Way galaxy. It's likely the result of a rare, bizarre game of galactic billiards among three massive black holes. Rather than gobbling up stars ahead of it, like a cosmic Pac-Man, the speedy black hole is plowing into gas in front of it to trigger new star formation along a narrow corridor. The black hole is streaking too fast to take time for a snack. Nothing like it has ever been seen before, but it was captured accidentally by NASA's Hubble Space Telescope. We think we're seeing a wake behind the black hole, where the gas cools and is able to form stars. So, we're looking at star formation trailing the black hole, said Peter Van Dokkum of Yale University in New Haven, Connecticut. What we're seeing is the aftermath. Like the wake behind a ship, we're seeing the wake behind the black hole. The trail must have lots of new stars, given that it is almost half as bright as the host galaxy it is linked to. The black hole lies at one end of the column, which stretches back to its parent galaxy. There is a remarkably bright knot of ionized oxygen at the outermost tip of the column. Researchers believe gas is probably being shocked and heated from the motion of the black hole hitting the gas, or it could be radiation from an accretion disk around the black hole. Gas in front of it gets shocked because of this supersonic, very high-velocity impact of the black hole moving through the gas. How it works exactly is not really known, said Van Dokkum. This is pure serendipity that we stumbled across it, Van Dokkum added. He was looking for globular star clusters in a nearby dwarf galaxy. I was just scanning through the Hubble image and then I noticed that we have a little streak. I immediately thought, oh, a cosmic ray hitting the camera detector and causing a linear imaging artifact. When we eliminated cosmic rays, we realized it was still there. It didn't look like anything we've seen before. Because it was so weird, Van Dokkum and his team did a follow-up spectroscopy with the W.M. Keck observatories in Hawaii. He describes the star trail as quite astonishing, very, very bright and very unusual. This led to the conclusion that he was looking at the aftermath of a black hole flying through a halo of gas surrounding the host galaxy. This intergalactic skyrocket is likely the result of multiple collisions of supermassive black holes. Astronomers suspect the first two galaxies merged perhaps 50 million years ago. That brought together two supermassive black holes at their centers. They whirled around each other as a binary black hole. Then another galaxy came along with its own supermassive black hole. This follows the old idiom, two's company and three's a crowd. The three black holes mixing it up led to a chaotic and unstable configuration. One of the black holes robbed momentum from the other two black holes and got thrown out of the host galaxy. The original binary may have remained intact, or the new interloper black hole may have replaced one of the two that were in the original binary and kicked out the previous companion. When the single black hole took off in one direction, the binary black holes shot off in the opposite direction. There is a feature seen on the opposite side of the host galaxy that might be the runaway binary black hole. Circumstantial evidence for this is that there is no sign of an active black hole remaining at the galaxy's core. The next step is to do follow-up observations with NASA's James Webb Space Telescope and the Chandra X-ray Observatory to confirm the black hole explanation. NASA's upcoming Nancy Grace Roman Space Telescope will have a wide-angle view of the universe, with Hubble's exquisite resolution. As a survey telescope, the Roman observations might find more of these rare and improbable star streaks elsewhere in the universe. This may require machine learning using algorithms that are exceptionally good at finding specific weird shapes in a sea of other astronomical data. According to Van Dokkum, the research paper was published on April 6 in the astrophysical journal Letters. The Hubble Space Telescope is a project of international cooperation between NASA and ESA. NASA's Goddard Space Flight Center in Greenbelt, Maryland, manages the telescope. The Space Telescope Science Institute, STSCI, in Baltimore conducts Hubble science operations. STSCI is operated for NASA by the Association of Universities for Research in Astronomy in Washington, D.C. So, are we confused? I don't know about you, but I certainly am. The black hole is a stationary black mass gobbling up planets, gas, cosmic dust, light and anything else that comes within its gravitational orbit. Or, it travels through space extremely fast, leaving a trail of newly formed planets. It's a standalone singularity, or it may smash into other black holes and become a supermassive black hole while traveling. So, what does this have to do with souls? In a way, everything, because it shows, if nothing else, that the universe and all in it is without doubt made up from the same matter. Singularities gobble up old planets or just planets in general, and singularities produce new planets all made from the same, one must assume, recycled matter. If the soul is a real-time entity, it also must be made of universally available matter. We must now put our sensible heads on and take a deeper look as to the soul's possibility as a universal concept. This is the end of Chapter 9. Thank you for watching, but before you hop on over to Chapter 10, do the kid a favor and please hit that subscribe button, like and share. I'll see you in the next chapter.